Hello, my name is Andrea Gearhart, and I am proud to call myself a chemistry teacher. I have almost 25 years of classroom experience, and I'm looking for a new position that will allow me to employ my years of experience, but also my drive to truly impact the learning of children, to truly inspire deep thinking and strong problem solving, whatever their future path may be. I'm just lucky to do that through the avenue of chemistry. So as asked, I would like to share some samples of curricula that I have contributed to and have written myself. In my years at Peters Township, I have written all levels of chemistry curriculum: applied, academic, honors, advanced placement, and also some physical science. In 2018, I co-authored the honors chemistry curriculum through the platform of On Hand Schools. We were asked to fulfill the requirements that this platform asked. So as you can see on the screen, course description, then we have our materials, the general pacing. We divided our course into units, and then what were the essential questions we wanted students to truly be able to honestly teach others about at the end. The big ideas, the materials, the state standards we are asked to match and be driven by the science and technology standards of Pennsylvania. We came up with also differentiated instruction ideas for our children of multitudes of academic levels. I would also like to share portions of the AP chemistry curriculum that I developed to be approved by the College Board. And so the course, I make sure matches the big ideas, the science practices, the essential understandings and learning objectives. So the big ideas, and then next we'll see the labs and the science practices, essential understandings, learning objectives, that all of those match, and so on. Every year, I get the approval from the College Board and the thumbs up from that. I would now like to share a sample lesson. And let me just go ahead and bring this up. So in the curriculums I've developed, we definitely have given, streamlined lessons, but to share a more detailed lesson plan, this is an example of the day one electrochemistry lesson that I do with the AP chemistry students to lay a foundation for their understanding of galvanic cells. And it starts with observations of operating galvanic cells, really inspiring them in teams to first look at and really take in what are the parts, and then to ask, well, why those parts? How are those parts doing electrical work from a chemical reaction? And so aligning, as you see in the left, to the Pennsylvania State Science and Technology Standards developed by our Education Board, as well as the College Board standards. And then I would bring the students back, really drawing in their observations and trying to build then an operating galvanic cell. And so based upon their observations of what's in the beakers and why those ingredients, and what is electricity, and how do we get the parts of this chemical reaction to move electrons to do electrical work for us, all the while bringing to their attention new terminology: anode, cathode, salt bridge. Worked with a voltmeter before, but what is it doing for us? And then at the end, can I give them a drawing, and can they label the different parts? And we'll keep relying on this as we learn more about galvanic cells with different ingredients, concentration cells, non-standard conditions, and then electrolysis. So this really starts with their observations and their attempts at explaining, and then, proves, disproves, builds upon to really arrive at how does a galvanic cell work. We also were asked to share sample assessment questions. I do, especially first, I'll share some from honors chemistry, because you're walking a fine line between it being a first year course and having them do some recall, some simple recall, especially in the beginning of an assessment to build their confidence, but then asking them deeper questions. So they're not just, naming a physical property or of the list, which is a physical property, but even just changing the wording slightly to a physical property may be revealed when. And so it just sets a little bit more of a real world scenario for them. I am a big believer in requiring the students to really imagine on the atom and molecular behavior level. So with particulate diagrams, can they do, a matching, a connecting, but then also what particulate diagram is showing a physical change, a chemical change. For short answer questions, I really expect that the children apply and explain and really prove. And so the short answer questions that I like to ask get into those deeper level 3, level 4, but yet building on level 1 and level 2. In AP, a little more recall, but they're going to have to make connections from the recall. So the first example question, it's not just what is the hybridization on carbon in CH4, but what would the hybridization and the bond angle be? And so just a little bit more involved. If given a statement, if given a claim, can they provide the evidence and the reasoning that justify it? So I really like those kinds of questions that really require the student to not write a lot, but to write quality and really rely on the correct terminology to communicate understanding. I love the questions that give a student conclusion, especially, and then ask another student themselves to back up, to support if the student was correct or incorrect. And I love questions that maybe on the surface seem, level 1. Here's list the measurements that students would need to experimentally find the enthalpy of reaction of a specific type of ingredients. Well, they'd have to figure out, what do I need to collect in order to calculate it? For example, they'll need to employ in their calculation change in temperature, but you can't directly measure change in temperature. They'll have to measure initial and final and then find the change. And so in entertaining questions like this, they're really, really pushed to really apply scientific method, their experimental understanding with a theory that has been involved in class. And they would have, done a lab or entertained questions like this very similar. So it's really measuring that understanding. I look forward to talking more about my experience, about my enthusiasm for the educational process and really learning. I'm excited about the opportunity to apply my talents and skills in a little bit of a different setting, such as Instructure. Thank you very much. I look forward to hearing from you.